Hello, this is Mr. Collier, and today we're rationalizing the denominator. Okay, so rationalizing the denominator basically means not having a surd in the denominator. And that's useful for many reasons, one of them of which is easier to add surds together when the denominator is rationalized. Okay, so to get rid of the root 5, we need to multiply the numerator and denominator by root 5, because obviously that'll get rid of the surd in the denominator. So your numerator is 5 root 5. Your denominator is root 5 times root 5, which is 5. So that is root 5. Okay. Another thing you could have done here is you could have recognized that root 5, or 5, is root 5, root 5. So you could have gone straight to the answer this way as well. Or you could divide the numerator and denominator by root 5. That works as well. Here, same thing, it's just a variable, so you're going to have 3 root a over a, and that's it. Now, when you have this kind of situation, you might think you can multiply by root 5, but then this term here is going to have a root 5, so multiplying by root 5 doesn't work. Turns out multiplying by this quantity works, and it basically works because, well, you know that a minus b times a plus b, difference of squares, results in a squared minus b squared. So if a or b are surds, you're going to square them, and the surd is cancelled. So that's how it works, and it's so common to do. We got a name for it. It's called multiplying by the conjugate. This thing is called the conjugate, and on the numerator you get 3 root 5 plus 3, and the denominator you're going to get root 5 times root 5 is 5, and a minus 1. So that's a 4 in the denominator, so you can write it like this. Or you can write it as like 3/4 root 5 plus 3/4, if that's better for you. So same thing here, you can multiply by what we call the conjugate, and it cancels out the surds in the denominator. Make sure you multiply by the conjugate of the denominator, not the numerator. Okay. Multiply by that. In the numerator, you're multiplying 4 terms together, so root 6 times root 6 is 6. Now, root 6 times, okay, that's negative root 12, and this is going to be a negative root 12, and root 2 times root 2 is 2. Your denominator is always, like I said, a squared minus b squared, so that's root 6 squared minus root 2 squared, right? And this is 8, and 12 is root 4 root 3. Okay, so that's 8 minus 4 root 3 over 4, and you can divide both these terms by 4, and you get 2 minus root 3 is the final simplification. Same thing here, you can multiply by the conjugate, q plus root p over q plus root p. So you get q plus root p over q squared minus p. And lastly, you can multiply by the conjugate directly in this one, but it's easier if you clear the fractions first. So yeah, then you want to get rid of the 3 basically. So 3's cancel, you get root 3 plus 3 over 3 minus root 3. And then multiply by the conjugate, and this is a bit easier. The conjugate of the denominator, so that's 3 plus root 3. Let's multiply the numerator and denominator by 3 plus root 3. In the numerator, let me go a bit to the left. Numerator, you got 3 times root 3, so 3 root 3. And then you got root 3 times root 3 is 3. 3 times 3 is 9. 3 times that gives you another root 3. Denominator is 9 minus 3. And then you've got up here 12 plus 6 root 3 over 6, and you can divide both these values by 6, so you get 2 plus root 3. Very similar to what we got the first time.